Hello, and we are going to start chapter 9 today. And chapter 9 is polynomials and factoring. And 9.1 is adding and subtracting polynomials. Polynomials are just a many-termed expression. Remember what the word term means. A term is separated by a plus or a minus sign. We've done that before. X plus 2. You have two terms. X is a term, 2 is a term. Plus sign in between. If you have 2x, there's one term because there's no plus or minus sign. So a plus or minus sign determines how many terms you have. All right? A polynomial is a many-termed expression. We have three special polynomials. A monomial, which is a one-termed expression. And I gave you several examples of a one-termed expression. Just x, 3x, 4abc, -7xy cubed c squared are all one term. There are no plus or minuses. 4abc has four factors, four things being multiplied, but nothing being added or subtracted. And that's what a term is, an addition or subtraction. Okay, that's what you're looking for. Binomial is a two-termed expression. So now it has two terms, x plus 9. X is a term, 9 is a term. 2x minus 6y. 2x is a term, 6y is a term. X squared y cubed minus 9ab. Again, the x squared y cubed is one term because there's no plus or minus sign in between it. And the same with the 9ab. That's one term. So one term in that expression is x squared y cubed. The second term in that expression is 9ab. The third type of polynomial is a trinomial, and that is a three-termed expression. And I gave you an example here, x squared minus 3x plus 8. X squared is one term, 3x is the second term, 8 is the third term. So you have three terms. Think of a bicycle also when you're thinking of monomial, binomial, trinomial. Mono means one. Bicycle, two wheels means two. Trinomial, tricycle, three wheels on a tricycle. So that you can also remember what those prefixes mean. The degree of a monomial is the sum of the exponents of the variables in the monomial. You'll have to excuse some of when I copied this onto the video, it kind of goofed up some of the printing. What is the degree of each of the examples above? Okay, so what is the degree of the example above in the monomial? So x has an exponent of 1, so its degree will be 1. 3x, the variable is x. Again, it has an exponent of 1, so its degree will be 1. If you look at 4abc, A has an exponent of 1, B has an exponent of 1, and C has an exponent of 1. Therefore, the degree of that monomial, which is the sum of the exponents of the variables, would be 3. 4abc would be, the degree would be 3. In the next monomial that I gave you, -7xy cubed z squared, you will see x has an exponent of 1. You have y has an exponent of 3, and z has an exponent of 2. So when you add 1 plus 3 plus 2, you get 6. So -7xy cubed z squared would have a degree of 6. What is the degree of each of the examples above? That's what we just did. The degree of a constant, remember a constant is a number with no variable, is 0. Why is it 0? Well, we can rewrite 3, the number 3, which is a constant, as 3x to the 0 power. Remember, anything to the 0 power is 1. So 3x to the 0 power is 3 times 1, which is 3. So it's just another way of writing 3. The degree, remember, of a monomial is the sum of the exponents. So if you look, x to the 0 power has a degree of 0 because the exponent is 0. The degree of a polynomial, so the degree of a many-termed expression, now you have an expression, more than one term, is the greatest degree of its terms. So you're going to find the degree of each term, and then the highest one is going to be the degree of the polynomial. The standard form of a polynomial is written from highest to lowest exponents and in alphabetical order. Okay, so ax, I don't know why that says question mark, that should be a squared. Ax squared plus bx plus c is your general formula of a polynomial. It's a standard form of a quadratic equation. A quadratic expression is one that has an exponent of 2 for its degree, okay, or the degree 2, I should say, okay? So for example, if you had 4x minus 6 plus 3x squared, and I told you to write it in standard form, you write it in alphabetical order, so there's only x's, and then from highest to lowest exponent. So your highest exponent is a 2, so 3x squared would be your first term. 4x would be your second term because x has an exponent of 1 there. And 6 would be your last term because its degree technically is 0 because it's a constant. The leading coefficient is 3. Think of what that's saying, leading coefficient. It leads off. The leading coefficient is going to be the coefficient of the term with the highest degree. Okay? Second example that I gave you, 4x squared minus 3xy plus y squared is in standard form. Again, remember, alphabetical order, highest to lowest exponent. So you had to get rid of the x's first. That's why 3xy came before y squared, even though y squared has a higher exponent. We have to go alphabetical order. So all the x's first, highest to lowest, then the next letter, which would be y. The degree is 2 because the highest exponent on any of the degree of the first term, 4x squared, is 2. The degree of the second term, 3xy, is also 2, 1 plus 1. And the degree of the third term, y squared, is also 2. So the highest degree is 2 on any given term, so therefore the degree of the polynomial is 2. The leading coefficient, the one that leads off, the one that's first, is 4. So that's your leading coefficient. So by definition, the leading coefficient is the coefficient of the term with the highest degree. So when you write the polynomial in decreasing order from left to right, that means highest to lowest, decreasing order, it's the first coefficient in the expression. Something very important to remember when asking to identify a polynomial is that a polynomial cannot have a negative exponent or a variable in the denominator or a variable as an exponent. So those three things cannot be in the expression if you're going to say it's a polynomial. Okay, so if I'm asking you to identify whether something is a polynomial or not, you're going to look to see, does it have a negative exponent? Does it have a variable in the denominator? Does it have a variable as an exponent? And if any of these three occur, then you are going to say, no, it is not a polynomial. It is not a polynomial. So the following examples, we have 5xy squared. 5xy squared. So Is it a polynomial? Yes. There are no negative exponents. There's no variables in the denominator, and there's no variables as an exponent. So yes, it is a polynomial. Okay. Now, what is it is one term. So one term is a monomial. So it is a monomial. Its degree, remember we add the exponents, so the x has a 1, the y has a 2, so that's 3. So the degree is 3. Why that doesn't write too well there, but the next example is 3a to the negative 5. 3a to the negative 5. So the exponent is negative 5. Therefore, not a polynomial. Next, 3. That should be a x to the 4th power. I don't know why the 4 came down. So x to the 4th plus 5x cubed minus x. So it is a polynomial. It has 3 terms, 1, 2, 3. So it is a trinomial. The degree of x to the 4th is 4. The degree of 5x cubed is 3. And the degree of x is 1. The highest is 4. So the degree of this polynomial is 4. 9 over m. Well, we can't have m, a variable, in the denominator, so not a polynomial. The next one, 6a squared c plus 5ac, that should be to the 5th power. If you're looking at your notes, it should be correct because it's correct in the plus portals. So the first term, we have 6a squared c, and then the second squared term, 5ac to the 5th. So you have 2 terms. 2 terms is a binomial. So this is a binomial. And the degree of the first term is 3, 2 plus 1. And the degree of the second term is 1 plus 5, which is 6. The larger number is 6, so this has a degree of 6. The next section asks you for the degree of the polynomial that's there. Number 6, x to the 4th power, that should be the 4th power. So the degree is 4. The next is, what is the degree of 3x squared y cubed? Well, that's going to be 2 plus 3, so that's going to be 5. The degree is 5. Number 8, the first term has a degree of 3, the second term has a degree of 1, and the constant has a degree of 0. So the highest exponent is 3, or the highest degree. Number 9, that should be 6m to the 5th power. So it has a degree of 5. And the next term, 7n cubed p to the 9th power, would have 3 plus 9, which is 12. So the degree here will be 12. 9 over m, so you can't do it. And negative 3m to the 5th, that should be a negative 5. there in your notes. It was negative 3m to the negative fifth power. Well, we can't have negative exponents, so no degree. You can't do it. Not a polynomial. Okay, not a polynomial. All right, so that's the first section of 9.1. The next section in 9.1 is adding and subtracting polynomials. This is what we will be using more of than asking the degree and the number of terms, etc. But that's good to know. But this emphasis is going to be on adding and subtracting polynomials. So adding and subtracting polynomials. You can only add or subtract like terms. Well, what are like terms? Well, we've heard this before. When we're adding like terms in linear expressions, 2x plus 3x, we know those are like terms. They both have the same base. So we kept the base and we added the coefficients. 2x plus 3x was 5x. You're going to use the same rule here, only now we're going to have exponents that are involved. So like terms are the same base and exponent. Same base, same exponent, okay? When you add, you keep the base and the exponent the same, and you add or subtract the coefficients, the numbers in front, just the same way. You've done it before with linear expressions. So when we add 3x squared plus 2x squared, we're going to get 5x squared, not 5x to the fourth. We keep the base, the x the same. We keep the exponent, the squared, the same. We don't add them. Remember when we add exponents was when we were multiplying. We just did that in chapter 8. Okay, so now we're going to add. Another thing to remember before I start doing the examples, in which I have right up here. When subtracting, remember to change the minus sign to addition and take the opposite of every term inside the following parentheses. Because what are we doing? If we have a negative outside a set of parentheses, it's the same as multiplying by -1. So you're going to distribute that negative sign or that -1 over each term in the parentheses that follows it. So that's what you're truly doing algebraically, is multiplying everything by -1. But all you need to know to do is change the minus to a plus and take the opposite of every term in the parentheses that comes after it. Then everything will be its correct sign when you go to add and combine like terms. So if we're adding like terms in number 12, we have to look and see which ones are the same. Well, we have -2x squared and 3x squared. Those are like. So that's going to be 1x squared. Then we have 3x. Well, there's no other x's, so you just write down the 3x. Then you have -x cubed, and you have an x cubed. Well, when you add -x cubed plus x cubed, you get 0. They cancel out. And the only thing left is your -12. So your answer is x, I don't know why that does that, x squared plus 3x, you don't have to really rewrite it, minus 12. You would write your final answer in standard form every time. This one happened to come out that way because the cubes canceled out. Another way that you could have done this is lined up the like terms vertically. So I would have rewritten this first one in standard form, negative x cubed minus 2x squared plus 3x. And then I'd look at the second set of parentheses and I'd line the like terms up underneath each other. So 3x squared would go under negative 2x squared. X cubed would go under negative x cubed. And the 12 is not the same as the x, so I would put that over to the right. So now I have the like terms lined up vertically. So now you can just add down. Negative x cubed plus x cubed is 0. Negative 2x squared plus 3x squared is 1x squared. 3x plus nothing is just 3x. And then minus 12 has nothing added to it. So it's just going to stay minus 12. So my final answer is just x squared plus 3x minus 12. So this is called a horizontal method, was the first method I showed you. And this is a vertical method because you've put them one underneath each other. One underneath each other. Okay. It doesn't matter to me which method you use, whichever one seems to make more sense to you is fine. Number 13. Whoops. Number 13. Number 13, again, if we look at our like terms, we have 4x cubed and 1x cubed. That's 5x cubed. We have 2x squared and negative 3x squared. That's negative 1x squared. Remember now, standard form, highest to lowest exponent. So when we look to see what's left, we have a negative 4 left and an x left. We can't add them because they're not like. So we put the x next because we need to go highest to lowest exponent on the variables. So all the variables have to go first. Then the last thing you're going to do is put the constant. So 5x cubed minus 1x squared or minus x squared plus x minus 4. Now, if you wanted to do it vertically, we would take 4x cubed plus 2x squared minus 4. Now, I'm going to put the minus 4 over here because I know I have an x term in that next equation. So x cubed is going to go here underneath the 4x cubed. Then we have negative 3x squared. And then we have plus x. So now when I add these two, I get 4 and 1 is 5x. I get 5x cubed minus x squared plus x minus 4. So again, horizontal, vertical. It doesn't matter which way. So number 14. Sorry about that phone call. 14. We have 2c squared minus 8 minus the quantity of 3c squared minus 4c plus 1. So now we have a subtraction problem. So like I told you, when we have a subtraction problem, we have to change it. So you're going to change the minus to a plus, and you're going to take the opposite of every term that comes after it. So that 3 is going to become negative, that 4 is going to become positive, and that 1 is going to become negative. So now you have 2c squared minus 8 plus negative 3c squared plus 4c plus negative 1 or minus 1. It doesn't matter. Now you have to combine like terms. 2c squared and negative 3c squared is negative 1c squared. Now you have 4c, no other c's, so you just put the 4c. Now you have two constants. So you have a negative 8 and you have a negative 1. A negative 1 and a negative 8 is a negative 9. Now, if you wanted to, like I said, do this vertically, you would have 2c squared. Again, I'm going to put that 8 over here because I know I have a c term. Negative 3c squared plus the 4c and minus 1. I'm just going to bring it over here to the right. So 2 minus 3 is negative 1c squared plus the 4c and minus the 9. Again, we don't need that negative 1, so your answer, negative c squared plus 4c minus 9. And the last example, number 15, is also a subtraction problem. Okay, so again, we're going to take that minus sign and change it to a plus. That y squared is going to become positive, the 4y is going to become negative, and the 3 is going to become positive. Now you can add like terms. Like terms, 5y squared plus 1y squared is 6y squared. Then you have 2y and negative 4y. Careful of that negative. 2 and negative 4 is negative 2. And now you have two constants, a negative 4 and a positive 3. Negative 4 and positive 3 is negative 1. There's your answer. Again, can we set it up vertically? Yes, we can. You can have 5y squared plus 2y minus 4, and underneath y squared minus 4y and plus 3. That's a plus, not a minus. So now you have 5 plus 1, 6y squared. You have 2 and negative 4. That's a negative 2y. And negative 4 plus 3 is negative 1. Okay, and that's it. So it's a little more complicated than adding linear like terms, linear expressions. because now you have to make sure you keep the like terms together. So like terms again, remember, same base, same exponent. Keep the base and keep the exponent the same, and then you just add the coefficients. Now I have given you a worksheet to do, so you can use these notes and do your worksheet.